Hi, welcome back to Moose and Chemistry. This is the Ideal Gas Law Problems Lesson 1. In our first lesson with ideal gas laws, we explained the law. Now we're actually going to do some problems. Remember that the ideal gas law is PV equals nRT, where P is pressure, V is volume, N is the number of moles, R is the universal gas constant, and T is temperature. Okay, so now that we understand those, let's go ahead and figure out what we have. So again, I like to set this up as P, V, N, R, and T. Okay, so we have 230 liters as our volume. We have a pressure of 400 atmospheres. We have a temperature of 200 K. Now the R value is 0.0821 liters times atmospheres over moles times Kelvin. Okay, so now we're looking for our number of moles. Okay, so we're ready to set this problem up because we don't have to do any conversions. Everything looks good. So we're going to take PV equals nRT, and we're going to go N equals PV over RT. So we just rearranged our variables. So let's go ahead and plug in our values. We have 400 atmospheres times our volume, which is 230 liters, divided by our R value, which is 0.0821 liters times atmospheres over moles times Kelvin times our Kelvin temperature. Okay, let's go ahead and let's get rid of everything that's common. So our Kelvins cancel out, our liters cancel out, our atmospheres cancel out, leaving only our mole value. So now all it is math. So let's go ahead and take this and let's clear this out and let's use the calculator. 400 times 230 liters, which gives me 92,000 on top, divided by, and let's see here, 0.0821 times 200, and that gives me 16.42, and we're looking at moles here. So this is going to be a pretty big number. It looks like 92,000 divided by 16.42, and wow, we have a huge number of moles here, guys. N equals 5,602.92 moles. Okay, well, that answer does make sense. Okay, so let's go ahead and clear these drawings out and let's try one more problem. So I'll be right back. Okay, so we're back with our second problem. If I have a 70-liter container that can hold 47 moles of hydrogen gas at a temperature of 300 degrees Celsius, what is the pressure of the container? Okay, so first of all, we write PV equals nRT. So let's write down what we know. We're looking for pressure already, so we know we're looking for that. Our volume is a 70-liter container. Our N value is 47 moles, so we're doing pretty good there so far. So far, so good. All right, looks pretty easy. Our R value, of course, is 0.0821 liters times atmospheres over moles times Kelvin. And our T is 300 Celsius. Uh-oh, look at that, 300 Celsius. We can't use Celsius, so we need to turn that into Kelvin. So K equals C plus 273.15. K equals 300 plus 273.15. Kelvin equals 573.15 K. So now we're going to go ahead and erase that number here, and we're going to plug in that other number now because we did our conversion. And we need to do that because of that right there, because that's Kelvin. Okay, so let's see, that gives me 573.15 K. Now we're ready to do this. So P equals nRT over V. All right, so now let's plug in our numbers. P equals, and our N value is 47 moles times 0.0821 liters times atmospheres over moles times Kelvin times our temperature, which is 573.15, and it's going to be K, divided by our volume, which of course was 70 liters. So liters cancel liters, Kelvin cancels Kelvin, moles cancels moles, leaving only our atmospheres left. So it's just a simple thing of using our calculator. So 47 times 0.0821 equals times 573.15 equals divided by 70. So our pressure is going to be exactly 31.59 atmospheres. And that answer makes complete sense. All right, guys, so you guys have an awesome day, and we'll see you back here at Moose and Chemistry in the future.